Hey boys and girls, Mr. D here. What we're going to do in this video is we're going to take a look at how to use the Pythagorean Theorem to help us figure out the sides of a right triangle. Okay, right triangles only. Pythagorean Theorem only works with right triangles, okay? Again, as you watch this video, remember to copy down everything you see on the screen and also add in any other notes you feel pertinent from what I'm talking about. You do not need to copy these pictures down here necessarily, but just this one up here is really how Pythagorean theorem was proved back in ancient Greece. And then here's just a little picture, a little application of how we can actually use the Pythagorean theorem. Let's jump right in here. This is the Pythagorean theorem right here. A squared plus b squared equals c squared. Here's the picture of our triangle. Side A and side B, they are always the legs of the right triangle. They are interchangeable. Okay. However, C is not interchangeable with A and B. C is always the hypotenuse, which is the side opposite from our right angle, as detailed here in with our little box. But C is always the hypotenuse, which is always the longest side. That's really important because that goes alone on the other side of the equation, separate from A and B. All right, and again, this little box here, this tells us this is a right angle. So thus, it's a right triangle, and we can use the Pythagorean theorem. Okay, so let's take a look here at an example. Here's example 1. All right, it says determine the missing side length of the triangle. Again, here's our formula for Pythagorean theorem. And let's just set it up again. It doesn't matter which one of these we use for A and B, but this x has to be our c because it's opposite from the right angle. So let's set it up. Let's just use A as 6. I've got 6 squared, and 8 will be our b, so plus 8 squared. And x is our c, so we can either write x squared or c squared. I'll write x squared just to avoid any confusion, so you can clearly see which side is which. All right, and here we just go through and do our math. 6 squared we know is 36, plus 8 squared, which we know is 64. Okay, so that's going to still equal x squared. We bring that down. 36 and 64, well, that's 100. All right, now, in solving this, we've got a variable being squared all alone by itself. In order to get this variable alone, we're going to take the square root of both sides. So we'll take the square root of 100, and take the square root of x squared. Again, you can do whatever you want to any equation as long as you do it to both sides. This is going to help us get x alone, because x times x will give us x squared. So really the square root of x squared is just simply x. Remember, square root of something, we're going to know what times itself will get us this interior number. Right? What times itself will get us x squared? Well, x times x gives us x squared. Just like we want to know what number can you multiply by itself to get us 10, to get us 100. And that number is going to be 10, right? 10 times 10 is 100. So therefore, x equals 10. So that means this side of the triangle is 10. Okay? Let's take a look at another example. All right, here's example 2. I'm going to determine the missing side length of the triangle. Notice now, they've given us the hypotenuse. We've got to find one of the legs. Use the same formula. Okay? So again, our formula, I didn't write it here. Now, let's see if you remember it. If you remember it, you can shout it out at home, make your parents look at you and think you're funny. All right? A squared plus b squared equals c squared. And again, these are our a and b's. They're interchangeable, okay? So we'll count this as x squared plus, this is our b, so 10 squared. And then c in this case is 26. All right, let's fill in here. X squared plus 100 equals, and 26 squared is going to be 676. And you've got to memorize your perfect squares up to 25. 26, I know is easy. You can see there's some 6's repeating here. Okay. I should have pulled this out earlier. Sorry, guys. But again, this is what we talked about again. A and B are the legs. So this is A, this is B, right in here. And here's our C. It's always the hypotenuse. So this side, the C, always goes on the opposite side of the equation from the A and B. You cannot mix that up. That's important. Okay, it's 676. All right, now let's solve for x. And you got to get x all alone. So let's move the 100 over. So we'll subtract 100 on both sides. And you can do whatever you want to an equation, as long as you do it to both sides. Right, so in this case, right, we're subtracting 100 on both sides. Okay? So let's continue to simplify. Over here, positive 100, negative 100, that's going to just cancel each other out. We've got our x squared. And over here, we got 576. Again, as you get to memorize your perfect squares, you're going to know that 576 is a perfect square of a number. Let's move this guy over here. All right, so at this point, we got to get x squared. We got to make x squared into x. In order to do that, we take the square root of both sides. Square root of x squared. Square root of 576. And as I was saying, I know the square root of 576 is 24. Okay, and I know the square root of x squared is x, right? So x times x gives me x squared. 24 times 24 is 576. Okay, so the length of this side right here is actually 24. Okay, so there's two different examples, and basically that's going to cover the bulk of your Pythagorean theorem questions. You notice in this one, where you're solving for either A or B, in our first example we had to solve for C. So please take note of which one you're solving for. Are you solving for one of the legs like we did here in example 2? Therefore, the equation sets up a little differently. Your variable is over on this side with the other leg. If you're solving for the hypotenuse, your variable will be already alone on one side. You just got to take the square root of it after you simplify. Okay? Hope this helps, and we'll do some more practice in class.